physical change is a change that occurs, it's a change or reaction that only changes the substance appearance. Okay, so something occurs to an object or a substance, and it only changes its appearance. And so things like, obviously like this pencil was a whole one before, and when it was broke, that was a change that occurred to it, and that is a physical change. Because all it would change the pencil's appearance, it did not change what the pencil was. And so like I could break it again, and that was still just a physical change. Okay? So physical change is when you change the appearance, but not the substance. A chemical change is a change that you not only change a chemical change is a reaction that changes that substance into a whole new substance. So if I were to take a lighter and light the pencil on fire, that would be a new substance after I did that, which would be a chemical change. Okay, so it's just like chemical and physical property. The only difference is that in property, we are describing property, or we're describing things about the substance, and change, the substance has actually undergone some kind of change. Okay. So not super complicated. Like I said, we talked about physical and chemical property a lot already. And so the physical and chemical change is something that we've learned about just because we've talked about the properties. Okay, let me have some people give me examples of a physical change. About Josh, can you give me an example of a physical change? So remember, it's when we change the appearance of something, but not change the object into something new. We'll come back to you, okay? So think about it, we'll come back to you. All right, Clayton. Okay, good, yeah. If we take the eraser off the pencil, you made a physical change. Not a big one, but a little bit of a physical change. Okay, what else? Alan? You smash a bottle, yeah. That's definitely a physical change, okay? Let's see. One more, and then we're going to come back to you, Josh, okay? Think about something. Riker? Okay, so the balloon, right, it's like a kind of a rubbery plastic. A latex, I think, is actually what balloons are mostly. And so when you pop them, it changes the appearance of that balloon, the shape of it. And so that would be a physical change. Okay, Josh, what do you think? How do you think you could physically change a piece of paper? Okay, good. Very good. So you could rip a piece of paper. That would be a physical change. It would change its appearance, but not what it is. Okay? Now, chemical changes. Let's get some examples of a chemical change. I know I'll only do a couple because I know this one's a little less. We don't know as many chemical reactions as other ones. You got one? If you get paper wet, now if it's wet long enough, it will do a chemical change because it will dissolve, and so that's a good one. If you only get it wet a little bit and then let it dry, then that is a physical change. But if you leave it in the water long enough, it's a chemical change. Braxton? Yes, very good. Yeah, the chromium oxide, or there's some type of chromium oxide. You're right. That was a chemical change. That little volcano thing that they did, chemical change, you can tell because its appearance changed quite a bit and it was a new substance. And there's actually, yeah, Liz. Yeah. And what's the popular one we all know about? Adding two chemicals into a bottle and watching it explode. Yeah, Alan. It is baking soda and vinegar. Yeah, that's a chemical change. A couple of indications that we had a chemical change. Now these aren't 100%, but these are good indications. If you have a color change, a lot of the time you probably had a chemical reaction. The exception to that is when you draw on a piece of paper. That is a physical change. Another one, if you produce a gas. So if you do something and it creates a gas, most of the time you are making a chemical reaction occur. An exception to that is like boiling things. If you boil water and it turns to steam, that's a physical change, not a chemical change. So there are exceptions to these, but these are pretty good indicators. Let's see. If you have two liquids and they go to a solid, so you combine two liquids and you produce a solid, that is often an indication of a chemical change. And if you create a new smell, that often means that you had a chemical reaction occur. So we can think about, or actually not we can think about, but let's talk about eggs. If you leave eggs out for a long time, what happens to them? They rot, and then if you break them open, it smells pretty bad, right? That's actually an indication that egg has gone under a chemical reaction. It had a chemical change occur, and it creates a lot of sulfur, which is the really bad smelling rotten egg smell. So, yeah, those ones are good indications of chemical reactions occurring. Have any questions? Okay. So